Math teacher is going to explain you sine, cosine and tan in a way that even a small kid can understand it easily. Let's take an example of a forest officer who wants to measure a height of this tree. The tree is very big, so he doesn't want to climb on it because it's just too much work, and he's going to use the knowledge of sine, cosine and tan to come up with the height of this tree very easily. So first he will measure the distance between himself and the tree. Let's say it is 50 feet. Then he has an instrument using which he can measure an angle between the ground and the top, the notch of the tree, from where he's looking. So let's say that angle is 30. Having this knowledge, now you can figure out the height of the tree, and we'll see how. Let me represent this as a right angle triangle. So here, right angle triangle is something where this particular angle is 90 degree, and I'm just taking an example here. Let's say the height is 3 and the base is 4. For such a triangle, this angle will always be 36.87. That's like the law of nature. What is law of nature? Well, 2 plus 3 is always 5. That is law of nature. Similarly, if you have a triangle, right angle triangle with height 3, base 4, this angle will always be 36.87. If your height is 4, the angle will always be 45. If your base is 5, the angle will always be 38.65. So it's kind of a fixed mapping that nature has. Can we represent the relation between this angle and these two sides in a mathematical form? That is what mathematicians do. They conduct scientific experiments and then they find some relationship and they just give a name to those relationships. So sine theta cos theta is not a rocket science really. It's just a relationship. It's a name that they gave to some natural law. So 36.87 is related to 3 and 4. We can also say that 36.87 is related to the ratio between 3 and 4, because if you change this ratio, this angle will change. And if the ratio is constant, let's say if 3 by 4 is 0.75, then this relationship is kind of constant, So mathematicians gave this relationship a name, tangent. They call this tan theta. Okay, so tan of 36.87 is 0.75, and you all know 0.75 is opposite side divided by adjacent side. Therefore, tan theta is opposite side by adjacent side. You have studied this in your math class, but I just represented the whole concept in a little different way so that you understand that it's a natural law to which mathematician gave this fancy name called tangent. If you take different triangle, then you will find that tangent of 10 degree is 0.176. This is fixed. It's like a fixed mapping. Tan 45 is always 1. So basically you can create this kind of mapping table. Tan 1 is 0.0174. This is fixed mapping that exists in nature. If you want to find out tan of any angle, you can go to this website rapidtables.com. I encourage you to try it out. Try out different angles and you'll find that tan 30 is always 0.577. It's like always fixed mapping. Now let's use that to solve our problem. So we know that tan theta is opposite side divided by adjacent side. Here opposite side is x, angle is 30, adjacent side is 50 feet. You can use your mapping table and tan 30 is 0.577. Substitute that here and you all are, I think, good with this level of basic math. You can figure that the height is 28.85.
La 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 लो रे अरे रैश क्रीम बची है
5. Okay, so 28.85. This forest officer, if he or she studied math properly during the school or high school days, they will be able to figure this out and they will save a lot of effort of measuring height of the tree. You can realize now that tan theta cos theta, these are not just the concept you study in the school, they have real life application. How about sine and cos now? A curious cat is now asking this question. In order to understand that, you need to understand Pythagoras theorem. So there was this uncle, very wise uncle called Pythagoras. He existed back in, I don't know, like few years, many years back actually. So he invented this Pythagoras theorem, which says that the square of hypotenuse is equal to the square of individual side, and you just sum it up. So here the square of the individual sides is 25 and hypotenuse is 5 basically. So that's the Pythagoras theorem, very basic. You probably know about this already. Now let's try to understand sine and cosine by taking another real life example. Let's say you have a heavy package lying in front of your home and you want to drag it inside your room. I know you'll have stairs, etc. But let's say the surface is flat. You can attach a rope to it and you can try lifting it. Now let's say you are putting a 10 Newton force. You know, Newton is a unit of measure for force. And then there is some angle. All right, so there is, let's say, 30-degree angle. Now part of this force goes into x direction and part of that force goes into y direction. And x direction is nothing but the component of the force that is used to pull the box in a horizontal position, and yf is the force that is used to lift the package a little bit. You need to lift it a little bit so that you can address the friction between the package and the ground. If you just keep the rope very straight, like horizontal, then it might be hard to pull the package. If you don't trust me, like, just try this out at your home. You will find it hard. You need to lift it a little bit so that the friction between package and the ground can be reduced. Now you need to apply exact right amount of force so that you can lift this package, with a less effort. And here, to find the components, the 10 Newton force has two components, x component, y component, and you can find this using sine and cosine, and we'll see how. Okay, so now here's the situation, and first let me find the component that's really used to pull this package up. All right, now in this beautiful picture, you again know that it's a law of nature that this angle 30, this 10 Newton, yf, xf, they are all related. It is also a law of nature that if you know this 10 Newton and 30-degree angle, just these two, you can actually find yf. And that law is expressed as sine. So sine theta is basically opposite side divided by hypotenuse. So that's your equation. And again, if you do sine 30, it's a fixed mapping. Sine 30 is always 0.5. Since the Big Bang, since the universe existed, sine 30 has always been 0.5, my friend. And if you don't believe me, again, go to this website, try out, you will see sine 30 is 0.5. Okay, let's put that into equation, 0.5. And with easy math, you can figure out that the vertical component with 30 degree will be 5 Newton. Similarly, xf. So xf has a different relationship and it's called cosine. Cosine is always adjacent side divided by the hypotenuse. And that's gonna be cos 30 is always again 0.866. And that's gonna be 8.66 roughly. So now again, if I studied math, sine, cosine, etc. really well during my math class, maybe I will be able to pull or push whatever this package really well. This is a very primitive example, by the way, but sine, cosine and tangent are used heavily in mechanical engineering, civil engineering, different branches. These are the concept, they have a real life application. So just to summarize, these are the equations of sine, cosine and tan. And as this video is part of the series, I have this series called Math for Data Science. Now, why is this video part of that Math for Data Science? Well, in data science, you will learn about cosine similarity, which is used in natural language processing. So before you study cosine similarity, I thought I would give you a good understanding of sine, cosine and tan. If you like this video, please give it a thumbs up. And if you have any comment, post in a comment box below. Thank you for watching.